factor? Please listen to this carefully because this is important. What is the formula for quality factor? Quality factor is given by IXL by IR. IXL by IR. This is the formula for quality factor. Okay. Now, what is IXL? What is IXL? So IXL, this I and I gets cancelled out. So XL, you can write this as omega 0L by R. So when you are writing this XL here XL is the value of inductive reactance at resonance. Value of inductive reactance at resonance. Okay, this is the concept of XL, right? So you can write this as 2 pi F0 L by R. So what is F0? F0 is 2 pi multiplied by 1 upon 2 pi root over LC multiplied by L whole divided by R. Whole divided by R. So when I am writing about the voltage magnification, this is the voltage drop across the inductor or capacitor to the voltage drop across the resistor. So voltage magnification or Q factor, this defines the voltage magnification produced in the circuit, that is voltage drop across the voltage drop across the resistor. So this is important. So if you just rewrite this, so what will be the value? What will be the value? If you just rewrite this, you see this 2 pi and this 2 pi gets cancelled and you are left with Q is equal to 1 by R into root over L by C. So this is the formula for quality factor. This is the formula for quality factor. So quality factor, this is the voltage magnification in the circuit. That is voltage drop across inductor or capacitor ratio of voltage drop across inductor or capacitor to the voltage drop across resistor. Right? So this is the concept. This is the concept. Okay. So you have to know what is quality factor because this is important and you have to derive the formula for quality factor at series resonance. Quality factor formula at series resonance. So this is important. Okay. This is important. Noted this down. Now what we will do, we will move on to the next thing, that is bandwidth. Okay, so when we are considering bandwidth, we have to know how does the voltage across the L and C vary with frequency. How does the voltage across L and C vary with frequency? Okay, so this you have to first know. To know what is bandwidth, you have to know this first. Okay, so I think I'm clearly audible. So what you do, so what I write here, you see, I write variation of V and I across L and C with frequency. This you have to understand. This was not in your first year syllabus. This is important and this you need to understand thoroughly. Okay. Now first thing is, let's say, so just let me, I think Q factor is done, so I am focusing on this topic, right? So let's say voltage across capacitor. Let us focus on this. So how do you give this? This was equal to I into 1 by omega C, right? The voltage across the capacitor is I into 1 by omega C. Now, for a series circuit, right? What is I? Tell me what is I for this series circuit? Your I will be equal to, that is V upon R square plus XL minus XC whole square. This was your current, right? Okay. So replace this value of I here. So what will your VC become? Your VC is equal to V upon omega C into 1 upon R square plus omega L minus 1 by omega C whole square. Clear? This is your VC, right? This is your VC. Okay. So what we are doing is, we are squaring both sides. We are squaring both sides. Please look at this derivation. This is very important. Very, very important, this thing, for design of the filters. Right? So what we are getting? If any time you do not understand, you just stop me. So VC square will be equal to V square by omega square C square multiplied by 1 upon R square plus omega L minus 1 upon omega C whole square. Right? We have squared up both sides. We have squared up both sides. Okay. Next, we just simplify this. So this is V square by omega square C square, and this is multiplied by, if you break this up, what will be the value? If you break this up, what will be the value? Tell me what will be the value. This is 1 by R square plus omega square LC minus 1 by omega C, this entire thing's whole square. Okay. So if you just rewrite this, this will be equal to V square by omega square C square multiplied by omega square C square and divided by omega C square R square plus omega square LC minus 1 whole square. See, just simple simplification. We are doing simple simplification. So this thing and this thing gets, so you are left with V square upon omega square C square R square plus omega square LC minus 1 whole square. Okay. Steps. Look at the steps. Okay. So you are left with this. Okay, now what you are trying to find out? You are trying to find out the frequency at which the VC will be maximum. The frequency at which the VC will be maximum. Okay, so what you have to do to find out the frequency at which VC is maximum? So to find out the frequency at which VC is maximum, you need to do d t omega equal to 0. This is the concept of maxima and minima, right? dVc square by d omega, this will be equal to 0. This is the concept of maxima and minima. Okay, so if you write this down, this will be just something big enough. So dVc square by d omega, right? V square is constant, okay? V square is constant. So what you are left with is 1 upon this thing, and this will be equal to minus 2 omega c square r square plus, right, 2 into omega square LC minus 1 multiplied by 2 omega LC divided by this whole thing's square. See, please, anybody is having any doubt, please let me know. This derivation is important. I am again mentioning this. This derivation is important. So you can equate this to 0. This will be equated to 0. Anybody is having any questions, any doubts, please let me know. Okay. I am going slow with this derivation, that is why. Right? So if you equate this to 0, you see you are left with minus 2 omega c square r square plus 2 omega square LC minus 1 multiplied by 2 omega LC. This is equal to 0. Right? So you can cancel out the 2's. You can cancel out the 2's. So you are left with omega c square r square, sorry, minus omega c square r square. Okay. Or you can just simply put it down as this whole thing was actually equal to 0. So here there will be no minus, plus omega square LC minus 1 multiplied by 2 omega LC. This is equal to 0. So you can cancel out this omegas as well. So you are left with, if you just solve this, if you solve this, this is coming out as omega square L square C square minus 2LC plus C square R square is equal to 0. Right? See, I am going slow about this. Any doubts, you can ask me. Any doubts, you can ask me. Okay. So what it will become? 2 omega square L square C square will be equal to C square R square plus 2LC equals to minus C square R square plus 2LC. This L, this C and this C gets cancelled out. So omega square was equal to minus C by R square 2L square plus 2L by 2L square C. See, this is what it is coming out, right? See, just once go through this. I might be wrong, so just go through this derivation. This is getting cancelled out. These things are getting cancelled out. So I am left with 1 by LC minus R square by 2L square. Okay, omega square is equal to 1 by LC minus R square by 2L square. So what is the value of the frequency? So let's say FC, is the frequency at which BC is maximum, right? So what will be FC? FC will be equal to 1 by 2 pi root over 1 by LC minus R square by 2L square. So please check this out. Please check this entire derivation. I am just see. Just see if this is okay. You have to find out the frequency at which BC is maximum. So what you have to do equal to 0. Okay. Just check if this is okay or not.
So can you explain once again the third line 5 omega is
BC
cut?
is maximum.
What? Okay.
Auditrika ঠিক আছে? Is this okay? Or should I just okay? So now just resonant frequency. Your resonant frequency is given by Fr is 1 by 2 pi root over LC, right? So if you look at this, just look at this, right? C will be less than Fr. Fc will be less than Fr. Okay? Fc will be less than Fr. Okay. Next, the same thing you apply for VL. The same thing you apply for VL. This I will just write the steps. VL will be equal to I into XL. Okay. So what is XL? XL is omega L and I is V upon root over R square plus omega L minus 1 by omega C whole square. Okay. Similarly, what you can do, you just square it up. You can square this up. You can do V square omega square L square by R square plus omega L minus 1 by omega C whole square. You can do this. And then you have to find out dVL square by d omega, equate it to 0 and find omega. This you try at home. I will just give you what is the final result. I will tell you what is the final result. So the final result for omega is 1 by root over LC minus R square C square by 2. 1 by root over LC minus R square C square by 2. So you can see from this itself that this will give you the formula of FL. This will give you the formula for FL. Okay, and this frequency, this frequency is greater than omega 0. The frequency that you get here, that is FL. This is 1 by 2 pi root over LC minus R square C square by 2. This thing is greater than F0. This is greater than F0. Okay, so please focus on this. This is the frequency at which the inductance voltage is maximum. So please look at the graph. So if you are plotting, say this is F and this is V, let us say. So right, this is the curve of voltage with respect to frequency, and this frequency is Fc. This is the resonant frequency, and this is the that at which the inductance voltage is maximum. So this is the curve of voltage versus frequency. This is the curve of voltage versus frequency. Okay, this is the frequency. Please note down the curve. Please note down the curve. Okay, so this is the curve nature of V versus F. So if you are asked to draw the V versus F curve for an series RLC circuit at resonance, so this is the nature of the curve. This is your resonant frequency. This is the frequency at which FL is maximum. Now you see, if is very small, if your R is very small, let's say R is very small, that is almost tending to zero, almost tending to zero. So under this condition, you see your Fc will be equal to Fr, that will be equal to Fl, because this portion becomes zero, and for this as well, for omega c as well, this becomes zero. So Fc and Fl both will tend to Fr. So when the R is very small, when the R is very small, Fc is equal to Fr, and that is equal to Fl, right? Okay, see if this is clear. So next is I versus F curve. Okay, so Fc is equal to Fr is equal to Fl for R is very small. Now say you are drawing the I versus F curve. So this is your frequency. Okay, so we get two curves. This curve, this curve is for small r, small resistance, and this curve is for bigger r. So as the resistance increases, the current will decrease, so will be the curve nature. So the amplitude of the I curve decreases with increase in R. Similarly, when the R is small, the amplitude for this curve will be high. Now, this is your resonant frequency. This is your resonant frequency, which we are writing say as F0. This is the resonant frequency, say, which we are writing as F0. You have two other frequencies here and here. One is stated as F1, one is stated as F2. At this point, this F1 and F2, these two are known as half power frequencies. Please note it down. F1 and F2 are known as half power frequencies. Okay? At this particular point, the current dimension is 0.707 times of I. At this particular frequencies, the current is 1 by root over 2 times of the maximum current. Therefore, these frequencies are known as the half power frequencies. At F1 and F2, current is 1 by root 2 times of maximum. Okay. So initially, what was the power? Initially, our power was I0 square R. What is the power at F1? What is the power at F1? This will be I0 by root 2 whole square into R. That is half I0 square R. So this is half of the original power. Half of the original power at F1 and F2. So this F1 and F2 are known as the half power frequencies. Okay? F1 and F2 are known as the half power frequencies. Okay? Yes or no? Have
Yes,
you
sir.
noted this down? Yes, man. Yes, man. Anything you want to say?
No, sir. Clear.
Okay, so please note it down that these two are the half power frequencies. Why half power frequencies? Because the current is 1 by root 2 times of the maximum current, and therefore the power at these two frequencies is half of the original power. Okay. So now next is, these are the half power frequency. So from this, we come to the next thing, that is bandwidth and selectivity. Bandwidth and selectivity. Okay. So from this, we come to two more terms. bandwidth and selectivity. So you till now you know what is the resonant frequency. At small values of resistance, Fc will be equal to Fl will be equal to the resonant frequency, and you have two frequency points at the curve where the power in the circuit is half of the original power or the maximum power. The next is we come to the next point, that is bandwidth and selectivity. Now you see, I will go back to the previous point. Okay, I will go back to the previous point. So from where did I start off? So where did I start off? That I said I was equal to I0 by root 2. This I said I was equal to I0 by root 2. Okay. So if you are taking this, so this is the current at resonance, which is maximum in case of series circuit. Current at resonance is maximum in case of series circuit. This we pointed out in the last class, that current will be maximum, impedance will be minimum, right? So your I0 will be equal to V0 by R root 2. This is your I. See, please focus on this. What I said, the current at frequencies F1 and F2 are 1 by root 2 times of the current is maximum for the series circuit at resonance, right? So I0 is the current at resonance. Okay, so what is I0? I0 is V0 by R, because at resonance the impedance is equal to R. At resonance the impedance is equal to R. So the current at resonance is equal to V0 by R. So your I, that is the current, is equal to at F1 and F2. I, that is current at F1 and F2. Current at F1 and F2 is given by V0R by root 2. Okay. Now you also know this, that the general formula is I is equal to V upon root over R square plus omega L minus 1 by omega C whole square. This is the general formula. Right? So your V0 will be also equal to V. You already studied this last class. I said that as VC and VL gets cancelled out, so the current voltage across the resistance is equal to the source voltage. So you can write this as V by R upon V by R root 2, as VC is equal to VL. So source voltage is the voltage across R. Okay? As VC is equal to VL, so the source voltage is the voltage across R. This we have already studied in today's morning class. Again, your I is equal to V by root over R square plus omega L minus 1 by omega C square. So you can equate these two. What we are doing? We are equating these two. So your V upon R by root 2 is equal to V upon R square plus omega L minus 1 by omega C whole square. Square by 2R square is equal to V square by R square plus omega L minus 1 by omega C whole square. V square gets cancelled. So this comes out as 1 by omega C whole square is equal to 2r square. That is what will be this? So what will be this? Tell me. Is this okay? Is this okay?
Yes, sir.
Okay. So this is becoming omega L minus 1 by omega C whole square equals to r square. This implies omega L minus 1 by omega C is equal to plus minus r. Plus minus r. Okay? Up till this? Okay. So next is what will happen to the rest of the things. So you just rearrange this equation. So this is becoming C omega square LC minus 1 is equal to plus minus R omega C. So this is becoming omega square LC plus minus omega CR minus 1 is equal to 0. Divided by LC. Divided by LC. So this is becoming omega square plus minus omega R by L minus 1 by LC is equal to 0. Right? So you just write the two roots of the equation. So how will you write the two roots of the equation? This is minus b plus minus root over b square minus 4ac by 2a. So similarly, I will write this to equation. So this will become plus minus r by 2l plus minus root over, right? So what is it becoming? Plus minus r by 2l plus minus root over r square by l square minus 4 upon LC, that is plus 4 upon LC, okay, whole divided by 2. So this is becoming plus minus r by 2l plus minus root over r square by 4l square plus 1 by LC. So this is the expression for omega. These are the two roots of omega. These are the two roots of omega. Okay? These are the two roots of omega. Is this okay? So you see omega, that means the angular frequency at frequency F1.
Sir.
Yes.
So that would be R by 4L or R by 2L.
Which one? Here. This one.
So just above the statement. The final roots of omega, sir.
Yes, you are suggesting this one. This one.
Just below this.
This one.
Yeah, first term. Plus minus R by 2L or R by 4L, sir.
Here. No,
Yes, sir.
see, actually what I have done, this was, your B was only R by L. So I divided this two earlier itself.
Okay, sir. Then.
See, R by L, so I divided this by R by 2L plus minus this one. So when you are taking this 2 under the roots, this will go as 4. So this is becoming R square by 4L square plus 1 by LC.
Okay, sir. Done.
Okay. So omega, what is the omega? Omega is the angular frequency as frequency F1 and F2. Now, if you look at this, your C, this value is in picofarads. Okay. C is in picofarads, L is generally in millihenry or Henry, and R is in ohms or kilo ohm. Okay. So under this condition, when this is picofarad, so this 1 by LC, this value will be much greater than R square by 4L square. This 1 by LC value, this will be much greater than R square by 4L square. So that is, you can neglect this R square by 4H square. You can neglect this with comparison to 1 by LC. Okay, so what is this equation becoming? This equation is becoming omega plus minus R by 2L plus minus root over 1 by LC. So what is F becoming? F is becoming C, or leave about F, your omega is becoming plus minus R by 2L plus omega 0. This is your omega 0 is 1 by root over LC, right? So this is becoming the resonant frequency. So what are the two values becoming? What are the two values becoming? Omega 1 is omega 0 plus R by 2L, and omega 2 is omega 0 minus R by 2L. We have taken only the positive value of the frequency. Why the positive value of the frequency? Because frequency is always coming as positive. So this minus has no other meaning. So this is becoming omega 0 plus R by 2L, omega 0 minus R by 2L. So if you are writing F1, F1 is F0 plus R by 4 pi L, and F2 is F0 minus R by 4 pi L, or vice versa. You can write it as you wish. You can write it as you wish. Okay. So these are the values of the half power frequencies. These are the values of this derivation is important. So these are the values of the half power frequencies. Okay. Now next is, what is bandwidth? What is bandwidth? So if you write what is bandwidth, bandwidth is nothing but this is equal to delta F, that is F2 minus, or F1 minus F2. F1 minus F2. So if you do F1 minus F2, you will get this as R by 2 pi L. This is the formula for bandwidth. This is the formula for bandwidth. I will tell you why I am using this word bandwidth. Remember, bandwidth is equal to delta F, that is F1 minus F2. And F1 and F2, you have got this as F0 plus R by 4 pi L, and F2 as F0 minus R by 4 pi L. Okay? So delta F is F1 minus F2. That is equal to R by 2 pi L. Right? I think this is okay till now. That comes is selectivity. Next thing that comes is selectivity. What is selectivity? Selectivity is the ratio between the bandwidth and the resonant frequency. Del F by F0, and we prefer a good circuit should have a lower selectivity value. Lower the value of the selectivity, better is the circuit. So when will the value of the when will be the circuit be better? If its bandwidth is narrower. So if the bandwidth is narrower, circuit selectivity is higher, right? So if bandwidth is narrower, the circuit selectivity is higher. Okay, so these are the two important terms, bandwidth and selectivity. Okay, so you know what is F1, what is F2, what is bandwidth, and what is selectivity. Okay, from this we come to the last thing, that is filter. So under the filter you have two things, filter, high pass filter, band pass filter, band reject filter. Okay, so first thing, what is the utility of a filter circuit? Okay, so the main utility of filter circuit is, please write it down as I am writing, utility of filter circuit is to allow a certain band of frequency, of waves to pass through in order to reduce the harmonics and the disturbances in the circuit. Okay. So what is a filter circuit? Say you know your waveform is a sine waveform. Waveform is a sine waveform. Now let's say due to some external disturbances or harmonics, your waveform gets like this distorted. This is getting like this. Okay. So what will be the filter circuit doing? This will smooth the curve. This will smooth the curve. This will eliminate these disturbances and make this curve a smoother one. Or it will regain the originality of the wave. So these are the disturbances or harmonics that are disturbing the wave. So what is the filter doing? The filter is eliminating these disturbances and the harmonics. And this is maintaining this smooth curved nature. Okay. So what does the low pass filter, why is low pass filter? So I will just write it down. C as a table. So this will be of help to you. Okay. So see, I am writing inside of the table. Type of filter, allowed frequency, not allowed frequency. Okay. So low pass filter allows waves having frequency less than f0, does not allow frequencies greater than f0. High pass filter allows frequency greater than f0, prevents frequencies less than f0. Band pass filter allows waves having frequency f1 less than f2, but prevents frequency f which is less than f1 or f greater than f2. And what is band reject? This is allowing, but this rejects. So these are the properties or how you classify filters. This is why we started off with resonance. We started off with half power frequencies. This was the reason why we made that derivation of f0, f1 and f2 to finally get to this, that what are the filters, how you choose the filters to eliminate this harmonics in the waveform or this harmonics in the circuit. This is where we finally reached. Okay. Is this clear to everybody? See, I am waiting. You can note it down. Please note it down. This table will be of help. I will show you problems how where you can apply this. So we have a seminar from 3:30, so we need to end the class now. So that is why I am asking you, if you have any doubts, we will not proceed any further. We will continue from this on Thursday. We will show you how you choose the filter, and another thing is left, that is parallel resonance. Okay. So please let me know if this is okay. Any questions? Anybody? Otonu, Akash, Bimbayon?
No, sir.
No, sir.
Any questions? Sheoshi, Oritrika, Priyanshu? ঠিক আছে, এগুলো বুঝতে পেরেছো?
Yes, sir.
So please note this down. Okay. তো সকালে যারা ছিল তারাই এখন আছে। I will give the attendance just as the morning class. Just Kritika নেই, কৃতিকা জাস্ট নেই, তাই তো বাকি সবাই আছে। Okay, so any questions, anybody?
No, sir.
Okay, so we will continue from designing of filters in the next class. Okay, I'm just stopping the sharing. Okay.